In this video, we are continuing the presentation on lesson 3-1 about position, velocity, acceleration. This will be the first of many rate graphs we will read. So, this graph shows the position function of a radio-controlled car. We're going to answer these questions by connecting the graphical understanding of position, velocity, and acceleration to the analytical understanding that we've developed in the last few videos, the last few lessons. So, was the car going faster at A or B? Well, since this is a position graph, the y values here are position. If that's clear to you, great. If it's not clear to you, that's what this y-axis being labeled position means. And that means that to find the idea of going faster, we're going to want to look at velocity. So what will mean the velocity of this graph? Well, since velocity is the rate of change of position, the slopes here, the slopes here are going to be the velocity. Now this is ending up being very confusing for some students. The idea is the slopes would be the derivative of the y value, or the rate of change of the y value. So because we have the y values here, because we have the slopes, because we have the y values here, our positions, our slopes, our rate of changes will be velocity. Everything we say about this problem would be a little different if this were a velocity graph, which a lot of the homework questions ask you about, and which we'll cover way in depth in Unit 4. If this were a velocity graph, then the y-coordinates would be velocity, and the rate of change of those coordinates, the derivative of those coordinates, the slope of those coordinates would be the derivative of velocity or acceleration. So please focus on that when you complete the work for this unit. Was the car going faster at A or B? So we're tasked with asking, well, the faster thing, that's a velocity question. Is the slope at A, it's not like that, is the slope at A steeper or shallower than the slope at B? And neither of those tangent lines are really accurate, but you can look at the graph and see that, well, which part of the hill would be steeper to walk up. I would say that we're going faster at point B. So I would say B because the curve is steeper. And why does steepness have to do with it? Again, it's because the slope of this graph will be the derivative of the y values of the graph. The y values of this graph are position, so the slopes are velocity. When was the car stopped? Also a velocity question. How do I find the velocity? We want the velocity to be 0. So when will the velocity of this graph be 0? We're talking about between C and D. Sorry, C and D. And that's the slope which is the velocity, equals 0. So the slope is 0. You could also say because the position is constant, and that's also what it means to be at rest. We're not moving one way or the other. At which point was the car's velocity the greatest? This will also be point B. Now, if we're looking at all of the possible slopes here, it's a little inaccurate still. Looking at all the possible slopes here at each of these points, the only real competition comes from this side of the graph. But we're looking at velocity. So we're not looking at which slope is steepest overall. We're looking at which slope is greatest. The slope is greatest at B. It's not the steepest if we ignore whether we're going up or down. This slope is the biggest positive slope we see. And positive will always beat negative if we're just considering in terms of who's biggest. But when we're talking about speed, the answer has to be E. The absolute value of the slope is steepest. If we ignore the sign being negative, if we took the absolute value, we would agree that this slope is steeper than that slope. Now, velocity graphs would be different. Velocity graphs, I would have to read the y values as the velocity, and the slopes would be acceleration. So if you ask me these questions about velocity graph, everything would be much more different. So please take care while you're working on a graph of velocity to apply these ideas of how the slopes are rates of change into that situation. Take care, be careful, stay safe.